Hello, and what you're going to be doing in class today is an activity. It's a two-page activity. The first page, I'd actually like you not to use the web, although I'm going to show you one website that'll help you answer questions about when do you see these from Earth. But basically, you're going to be comparing the Earth to other terrestrial planets. The 4 terrestrial planets are listed right here. The Earth already has all its information calculated. You don't have to say when the Earth is best time to see the Earth because the Earth is the Earth. But I would like you to do this for Mars, for Venus, for Mercury, for Venus, and for Mars. The diameter is given for us, and you can actually use that 5A student diagram to fill out this data table. And then once you get all that stuff done, go ahead and fill out or answer these analysis questions. If you don't have enough space here, you can actually use extra paper if you wish. Okay, this is where the planets are today, and if you take a look, here's the Earth. The Earth has the moon going around it, and right now most of the visible parts facing this is going to be a crescent. It'll be a waxing crescent because we get to see a little bit of the right side if we're on the Earth looking this way. It's the left for us because we're on the outside. But if you take a look at Mercury's orbit really close to the Sun, the only time you get to see Mercury is either right as the Sun sets, looking in this direction, really low in the horizon, western horizon, or when Mercury goes around to this other side in about a month and a half, because it takes about 3 Earth months for Mercury to go around its year orbit. Mercury's year is about 3 of our months long. So when the Earth actually gets over to when Mercury gets over to here, Earth will only have moved a little bit, but we'll see it right before the sun rises in the morning. You'll get to see Mercury in the eastern sky, but right now it's in the western sky. Venus is higher because its orbit is farther out, and then Mercury is even higher than that. Jupiter can be even higher, except Jupiter's now in the morning sky. When the Earth was over here about 3 months ago, it was actually in the evening sky, but it got lower and lower in the horizon, and now it's actually in the morning sky. Saturn is pretty tough to see because it's in the direction of the sun. Okay, so you're going to be filling out that information, and the reason I'm doing this is because the second side of this activity is actually a web-based virtual scale of the solar system. It's coming from the University of Manitoba. Spelling on the website is going to be a little bit weird, but you guys are going to be doing it with Forest Park's data, and I've got it located right here. This is the way latitude is normally written, as degrees, minutes, and seconds north, or degrees, minutes, seconds, and south, or degrees, minutes, second, and west, or same thing for east. But this site actually uses a decimal system. It actually calls the northern hemisphere positive numbers. If this was south, these would be negative numbers, just like for longitude. East is positive, west is negative, so we're going to type in the information here, 38.6 for latitude, minus 77.38 for longitude, and then move the map around. Here's an actual form of the map. I'm actually going to do Walla Walla. I grew up in this house right here. That was my backyard, and then there's a park and a creek. It was a great place to grow. There was no Kmart, there was no McDonald's, Les Schwab tire shop wasn't there. This actually located right here was not Starbucks, not an Eastgate Mall, but there used to be a stockyard right here where I got to see all kinds of animals, pigs, cows, horses, lots of other things. Great place to grow up. But anyway, we're going to go ahead and use this. I've already typed in the information. I typed in things like this, and I'm going to update or center the map on there, and then I slid that over and I said go ahead and update the coordinates for there, and they threw in all this information. Okay, so what you guys are going to do, I'm going to center my old house as close as I can. I'm going to update the coordinates so you can see I changed it. I'm going to pick a sun. These are in millimeters. If I make the sun 1 millimeter, which is, it takes 25 of these to make an inch. Let's do 25 of them. If I do that, the orbits are going to be drawn. The planets themselves will be a lot smaller. So I'm actually going to make this a little bit larger. I'm going to do 10,000. This is 10 meters. And you can't really type in the rest of the information. You can actually decide colors for your orbits. I'm just going to use the defaults. It's going to go ahead and calculate. Now calculate the size. So instead of 10,000, it's 35. Earth is going to be about 100 of these, so it's 1/100th of the size of the sun. Jupiter is going to be about 1/10th of the size of the sun, and then you can see the size of the planets, and you can also see the size of the Kuiper belts. But then it's going to show you the distance. Mercury is going to be 41% of 1 kilometer, because the Earth is at about a kilometer, 77% of that. The moon is going to be 2,000th of that distance, because remember it goes around the Earth, and then 1.63 kilometers, 5.5, so it's basically 3 times farther, and then you go twice as far as that, and then twice as far as that, and then you go about 1/3 of that distance to make it all the way out to Neptune, and you can see the colors. So let's go ahead and draw the orbits. And it's centered on my house. Well, actually, it looks like it's centered about right there. That was a neighbor I used to mow. There's Mercury's orbit. If I zoom out a little bit, you can actually see all of Mercury's orbit, and then you can make out the yellow one for Venus, and then you can see the blue one for the Earth. There's the moon up there by, that Shasta Drive. And again, I grew up right there. So the moon is located up there, just very much like that website I just showed you. There's Mars. Don't see Jupiter yet, because remember, for Jupiter you got to go from 1.5 times as far away from the Earth, or the sun, as the Earth is. And now I got to go 3 times that distance. And there's finally Jupiter. And then go out a little bit farther and you can see white orbit of Saturn. And then go out a little farther, you can make out the purple, or they're saying violet, Uranus, the blue of Neptune, and then where's the Kuiper belt? Oh, that's this magenta thing out here. And then the Oort cloud they're saying is gray, but not 42 kilometers away. It's 1,747, which makes it not even on the Earth. And I can't see it. I wonder if if I reset all these things and I said this was 10, calculate, now it's 10 kilometers away, draw the orbits, and there's the gray. And we have to go in a lot farther to see the magenta. Go in farther to see, and that's as far as I go in to see the Earth. You can see the moon, you can see the yellow, you can see the orange, and the sun would be there. Okay, so that is a scale model of the solar system, and that is the end of this activity. I would like you, once you get this done, to get a signature. You're not going to be getting my signature, you're going to be getting the sub signature. So if you can get her signature on there, that's Miss Dowling. So get Miss Dowling's signature on there, and I would be appreciative. Then turn it in, and that assignment's over. Excuse me. I will get a study guide to you, I hope, next class, and that's it. Take care.